So, hello everybody, and good. Uh, how do I say? Okay. Let's just say good evening here. Right now, at least in my place, it's now uh, in Sarawak in Borneo. It's 10 to 26 p.m. here on 17th of May 2026. It's Sunday, so yeah. Well, what a great weekend time, you know. And also there's also good news is that I'm able to find the live stream. Okay, but sometimes it can be quite iffy from the Bilibis from the source that I'm using right now. It's from Bilibili actually. And yeah, I'm not 100% sure how which 100% source is it, but for one thing's for sure, it's not from Spacelands, but pretty close. We can actually go and look around if you want. So I'm going to give you something. So rather than wasting too much time, might as well I just go straight to the live. So, hello, everybody, and good evening here from Sarawak, from Borneo. It's right now 10:30 p.m. here on 17th May 2026 on Sunday. So yeah, a very good weekend here right now. And today we are going to see the launch of the Long March 8 for the Qian Qianfan Jigui, aka known as the set SpaceSail. If I remember, this is not SatNet. If I remember, this is a SpaceSail something like that. Yeah, SpaceSail. Yeah, this is not SatNet. This is a SpaceSail. Hence the name Qianfan. Qianfan Jigui, SpaceSail Leo, space. How do I say? SpaceSail Polar Leo Group 8. Yeah, this is confirmed Group 8, which is where there's 18 satellites to be launched for today. And this is essentially from A to R. And yes, I've already counted it before. It's 18 satellites where it will be launched on board the Long March 8 rocket. So, what a good name, you know. This is a group number 8 and also Long March 8 as well. You get it? It's actually pretty versatile naming. Okay, so what a nice name. So a nice numbering sequence. So yeah, that's pretty good. And I think, and yeah, for today, this will be launched from the Wenchang commercial space launch site, the WCSLS launch complex 2, if I remember correctly, or launch complex 1, whichever is it. But it's basically just side by side to the governmental version. But this one, even though the name bearing commercial, this is still technically under the government purview as well. But if I remember, this is a local government of the Hainan. Okay, just in case you want to know. And I'm going to show you straight away the launch site right now. Okay, so this is it. You're looking at this right. This is not some pre-recorded stuff. I actually found this. Okay, so pretty good. Okay, and also I hope it's okay. I hope you can see this. And yeah, for if you see why there's no sound and whatnot, there's actually a pretty good reason why. Because they're using they're mostly using copyrighted song here, so I cannot show you this stuff. So I rather you actually look at this one as well. Yeah. Oh yes, I was correct. SpaceSail Polar Leo. Yeah, what? Polar Leo Group. Ah, so you see, uh, this is what I found. Found a little bit lost here. Okay. Ah, how's about that? It looks nice and neat. And yes. Oh, looks like we have another frozen stream here. It's okay. Sometimes bandwidth problems and whatnot, but that's the proof. This is actually straight away live from from that place. Okay, so we are back again. So in case you want to know, this is from this Bilibili stream, from one of the, let's just say, space Chinese space enthusiasts here. You can see the copyrighted on the right screen there. So credits to whoever actually streams this stuff. Okay, and also this is some notice as well. You can see, so you know, this is not from my side, but for one thing's for sure, if you know how to scour all of this stuff, you can get this straight away. So what a nice point there, you know. And I hope you actually enjoy um the copyright free background music that I'm using. Okay, in case you want to know, you can check on the description. And yes, so far I'm still waiting for the from how do I say from I'm still waiting from the international rocket launcher site, where there's actually a reason why I want to use it, because as you see from the Bilibili stream here, it it does buffers from time to time, so it can be quite unreliable solution for me. But I'm also going to check out from my phone and whatnot. But in the meantime, just in case you want to know, this rocket is actually a combinational propellant as well. As usual, you know, this day and age, it uses the bipropellant liquid fuel rocket. But on the first stage and also the side booster stage, which actually straps with two strap-on boosters there, first stage and the strap-on boosters powered by the Carolox propellant, which is the liquid oxygen as the oxidizer, and then the liquid and then the super refined kerosene, the RP1. Essentially super refined kerosene essentially is like little to no lead contamination inside the rocket engines. Usually it can destroy the rocket engines a lot, especially in the operation, if it does have significant amount of the lead contamination. So usually they are using the super refined kerosene, very refined, up until it reaches almost, if I remember, the liquid itself, it can looks almost clear to slight pale yellowish color, in case you want to know. And the liquid oxygen, usually it depends on how concentrated it is, but usually it will goes into the light bluish color. Okay, for the usually on the super refined kerosene, it's going to use the room temperature, pretty typical. Okay, so you know what room temperature is, in case you want to know. It's just like what currently I'm living right now. Okay, with just a fan, and I believe some of you also living on that. And maybe in the best case scenario, it's like air conditioned kind of temperature, depends on where you are. But hopefully you don't set it too much, because it's going to be very bad for your electricity bill as well. Okay, but the liquid oxygen, if I remember correctly, is the negative 184 degrees Celsius. So that's actually pretty cold. And for the second stage, just to I almost forgot to mention this. The first stage and the strap-on boosters actually were powered by the, if I remember, with the YF 100 rocket engines. That one, from my understanding, is the either gas generator cycle or the closed loop stage combustion cycle. But in this case, if I remember correctly, it's more to gas generator cycle. Okay, so gas generator cycle, usually in a sense, is that you fit in some of the portion of the propellants from the both side. Okay, you move some of that propellant, you burn it inside the pre-burner chamber. Okay, it's not really that big. Usually it's smaller than the main combustion chamber. Okay, you burn it out. Okay, and then you use it to move the turbine, both turbine for the liquid oxygen and also liquid and also the rocket propellant one. Okay, so it can move inside. First one of the propellant, usually it can be either the liquid oxygen or the RP1. It will move first into the cooling, surrounding the, how do I say, the combustion chamber and also the rocket nozzles. First, it will move surrounding it, just to act as a cooling jacket itself, and the cooling wall, just to cool down the rocket engines first, before before eventually it will be moved, before the portion of the cooling as well move together inside the combustion chamber. And then at the same time, the combustion chamber, at the same time, this s- lots of this portion of the liquid oxygen, and also eventually with the RP1, it will be moved inside the combustion chamber, ignited, and then and then that's where you get the propulsion. And then this combustion chamber is pretty hot. It's around 3000 or 4000 plus degrees Celsius. And then when it moves into the de-larval nozzle, aka the bell shaped size, when it's reaching that choke point, usually it can goes around, at minimum it's around, usually it's not really too hot anymore at the point, but that's very, I mean, it's still pretty hot, but because it's choking point, of course, it can easily melt that choking part as well. And then yeah, if I remember, it's around 3000 or 2000 degrees Celsius. And then eventually when it's expelled out, to expel out from the nozzle, eventually it reaches around less than 2000 degrees Celsius, something like that. Okay, expel out, with the inside the combustion chamber. Usually it can goes with high, if I remember, higher pressure but lower speed. And eventually when it's choking out, that's where the pressure and the velocity of the rocket exhaust flame, usually it's kind of equal. And then when it goes out from the nozzle, okay, going out from the nozzle, that's where the pressure is low, but the rocket exhaust flame velocity is practically goes basically goes bonker around it. That's basically how the operation works in the nutshell on the first stage of the YF100. Okay, on the first stage, it actually powered by, if I remember, it powers by two YF100 rocket engines, while on the side booster, um, respectively, it only has one YF100 rocket engine. So in total, on the main boost part, it has four YF100 rockets engine. And then on the second stage, it's actually powered by the hydrolox propellant, which the hydrolox propellant stands for the same, liquid oxygen, the oxidizer part. But the difference is that on the fuel is the liquid hydrogen. Yeah, on the liquid hydrogen, the liquid hydrogen is even much more colder. If I remember, it's around negative 256 degrees of Celsius, so or 254 degrees Celsius. So it's pretty cold, in case you want to know. The, and the YF75, if I remember, is the stage combustion chamber. Okay, the principle is almost similar to the gas generator cycle, but instead of the sum of the gas generator cycle, where it has that small has like small nozzle being expelled out together with the main combustion chamber, instead all of that cycle is basically, it's like there is like a reburn there's like certain stages, like this, like that, but let's just say the operation is almost similar, but just the difference that because of the closed loop cycle, the closed cycle nature, technically you can get much better efficiency in comparison to the gas generator cycle. That's basically how the operation works. Okay, so that's it. But however, we do have live here from the international rocket launcher, so I'm going to use the stream instead because why not? Much better. So here we go. And also let me go with the okay. Let me go instead with the partial here. Okay. Um. Mm-hmm. Yeah. So that's how I works, you know. And then I'm using the extension, video focus, and let's go, shall we? Okay. Awesome. How's about it? Okay, looks like we still have T minus 24 minutes in, before the fight. But in this case, yeah. But in this case, I think, yeah. So here we have multiple of views. That's why I'm using the international rocket launchers. Okay. Okay. So that's why I'm using the international rocket launchers because it has multiple of views. So credit to international rocket launchers for compiling all of this view from different streams by the various Chinese space enthusiasts. But the rest of it, some small credit would be the space lands from what I know, and the other 2 3 more, maybe even 4 um, Chinese space enthusiasts that I that I don't have any idea how to pronounce it. So pardon with that. And yeah, probably also at the same time, maybe I can also try go here find some information as well. Oh yeah, I think we've been a very good idea. So you know how the YF-100 rocket engines looks like. Yeah. Oh yeah. Yeah, looks like I'm a little bit stupid here. YF-100 is the stage combustion cycle. So my pardon me. It's not it's not gas generator cycle. I'm sorry. I mean it happens, you know. And YF-75 because I also think only YF-75 is the gas generator cycle. The YF-100 is stage combustion cycle. So very sorry, I actually can get mixed up as time goes by. But one of the, I can say, arguably much easier way to figure out. Yeah, I'm very sorry. Sometimes I can get just slightly. Currently I'm a little bit sick, but no worries though. I'm still okay. Okay, so what's better? I can even show maybe something like this. I guess. Hmm. Let me see. This is better. YF-100 and then YF-75 should be. Let me see, because there's difference. YF-75D, that one is for as far as I know, it's either expanded cycle or stage combustion cycle. So I want to show you the correct one. I cannot show you the wrong version. If I show you the wrong version, I don't know what I even done with my life. Okay, but in the meantime, okay, that's very interesting. So YF-100, I can find it, but 75, yeah. Okay. So this is better that I can show you. So what you see here, this one is the YF-100 rocket engines being used on the both of the first stage and also the strap-on boosters. You can see this is how the design looks like. Pretty close chamber, isn't it? So this is what do we call as the closed cycle or closed loop cycle rocket engines. Here is the stage combustion cycle. This one is more on the oxidizer rich rather than the fuel itself. But Usually, the reason why you want to use the oxidizers part in comparison to using the rocket propellant one is that because it's much more colder compared to rocket propellant one, negative 184 degrees Celsius. So that's why I think why they use more on the oxidizer rich part in uh, as opposed to the super refined kerosene part. Okay, and another one that I also can show you is the here another this one is another detail. So I'll say credit to the b14643.eu. So yeah, I also learned quite a lot from this source, even though this website can be quite older, but in terms of look and design. But you can see this is the YF100 rocket engines here. Okay, in the nutshell, if you're very interested, you can check out this yourself. Maybe I should put it in the description, but it's okay. This is the YF100 rocket engines in the nutshell. And then later on with the YF75, yeah, this is the second cryogenic single chamber engine after the YF73 developed. Yeah, where is YF73? Do they actually put it up? Okay, they didn't put it up here, but it should be good. So you can see there is also quite a difference as well. YF75D further developed from the YF75, but you can see the difference. YF75D, which is not used in this Long March 8 version, only 8A actually uses the 75D using the D variant. This one is the YF75D, not using this mission, is the close expander cycle. Yeah, so this is close expander cycle. I was correct here. Finally. Okay. So you can see this is how it looks like. Okay. And also the YF75, you can see why I mentioned this is it open cycle gas generator cycle is that you can see there's small rocket nozzle even on the even how do I say on the schematics part, and also visible on the screen on the design as well. You can see that's why. But that's it. I'm not going to bore you too much. Okay, so that's it. That's pretty enough as well, shall we? Okay, and then probably one more that I can also put as well. Okay, we're still in. Okay. And in case you want to know why I do look a little bit unprepared for now, even before the stream, there's actually just a little bit of story. But let's just say my laptop weirdly broke on the way, so not a very desirable outcome, but it is what it is. But however, we still can go ahead. I mean, fortunately, we don't miss too much here. So yeah, so because even then there's not much information that we know about this one. Okay. So just be a little bit patient. You're still looking at the rocket launches, fortunately, but I'm going to give you a little bit of cover, just slightly. Okay. Let me see maybe in the meantime I can also tell you just a little bit why we are why on the why usually why usually Carolox propellant being used on the main stages, while on the second stage usually they prefer to use something like Hydrolox. Okay, just to give you in the nutshell, if you use the Carolox propellant, since the super refined kerosene, the RP1 rocket propellant 1, yeah, you can see the credits by the SpaceSail there. Okay, so since usually you want to use the kerosene part, the Carolox part on the first stage booster, is that because it provides way more energy density in comparison to I mean it provides very good energy density for the amounts of for the amounts of propellant density that it can gives. Like the more the more the more propellant you can get in one volume, the better. So usually on the first stage, it's pretty highly preferable. You want to use the Carolox part, while on the second stage you want to use the Hydrolox part, or this day you can also using the Metalox. Metalox is basically like, try imagine if you have this supercharged high liquid hydrogen, but even more denser than the liquid hydrogen. Just maybe you need to accept just slight trade-off with the carbon suit part, but otherwise still highly efficient as well. You want to use this propellant because it is much more thrust efficient. Okay, thrust efficient means you get more bangs per buck, basically, like better specific impulse in comparison to the to the Carolox part. Carolox part, even at maximum from what from even what SpaceX can actually stretch out, usually only can reaches around 320 plus ISP, the specific impulse, 320 plus of seconds per specific impulse. But on the upper stage, if you use the Hydrolox or the Metalox part, Metalox is basically like CH4, but in this case, because you liquefied it very, very cold, okay, not as cold as the liquid hydrogen part. Liquid hydrogen is negative 256. If I remember, for the liquid methane, okay, you just only need to call it around negative 156 degrees, if I remember correctly, Celsius. Okay, if the it's the CH4 part, when you liquefied it very cold enough, of course it's going to be LCH4, while on the liquid hydrogen it's going to be LCH2. So the reason you want to use it, because it's way more thrust efficient. Okay, way more thrust efficient, and especially it can gives you much better specific impulse. So from what I know, for the Hydrolox, even the best part, usually it can reach us around 420 plus. Even at maximum, you can actually stretch out 440 plus seconds of specific impulse. For the Metalox, it can be slightly lower. If I remember, where is the Metalox specific impulse? Yeah, I need to search it because I need to fact check this information. Okay, even at best, it will be around, yeah, it will be quite similar to the on the sea level. It can be quite similar, almost similar to what SpaceX able to achieve with their Merlin 1D Carolox propellant, but at least you have much cleaner burn. Okay, usually around 330 up until 350. If you can stretch it, maybe 360 seconds of specific impulse. But in the space vacuum operation, it will be around 370 to 390, maybe 400, almost matching the parity of the liquid hydrogen. Just slight, how do I say, slight trade-off, but otherwise it should be good. Yeah, Hydrolox. Yeah, usually specific let me see, sea level specific impulse. Maybe the better that I can. Yeah, but for the Hydrolox, if it's being used in the sea level, basically operations like currently in the launch pad in what's on, usually it can deliver around, I can say slightly better than liquid Metalox. Just at around 20 30 seconds of specific impulse should go on around 360, maybe 395. But usually 395 seconds is more theoretical though. But in reality, it's more like how many? It's more like at best almost max out 370. But even then, the reason if you don't want to use the hydrolox part on the first stage booster is, even on the strap-on booster, is that because it has a pretty worse propellant. It has a really worse propellant density in terms of the liquid hydrogen. So if I remember, the liquid hydrogen, let me see, hydrogen density, let's just say we take this in terms of maybe the best we can do is gram per square centimeter. It will be around 0.07085 gram per square centimeter, something. Not square centimeter, it's like cubic something. yeah, something like that. No, square would be like cm4. I don't know what I'm even talking about, but just you need to know it's gram per cm3. The cm by the power of 3. So this one is what I can tell you. And for the methane, in terms of the density, it would be around 0.4226 gram per centimeter cubic or square, something like that. It's gram slash cm by the power of 3. So you can see it's quite inferior in terms of liquid hydrogen. It's really quite inferior in comparison to the liquid methane. Plus that's why this day and age, why liquid methane is basically all rich in comparison to liquid hydrogen. Even though I'm pretty surprised why earlier space flight effort didn't go focus on this liquid methane part. I don't know, but I suppose better late than nothing. But yeah, even in my rough calculation, let's just say 0.07 and then 0.442, something like that. Yeah, if we go with the calculation, how many times denser of the liquid methane in comparison to liquid hydrogen. Okay, let me do my calculation. Okay, just be a little bit patient. Okay, 4226, and then divided by 0.4226 divided by 0.07085. Okay, so you can say liquid methane is almost 6 times more denser than liquid hydrogen. Or if I have to be very specific, I'm going to say the word here: 5.9647184897671. So, or if we try to sort of like round the number, it will be around 5.97. Yeah. So you can see why this day and age liquid methane are now being used in comparison to the can now being used as the both of the first stage and the second stage, as opposed to using liquid hydrogen. Even though liquid hydrogen is still used due to its practically already being used like decades, liquid methane is basically like still pretty new in aerospace stuff. But yeah, but I suppose lots of things we still can learn about liquid methane after all. I mean, after all, even the first successful orbital flight using the all metalox propellant, if I remember, is the Jigu 2, if I remember correctly. The Jigu 2, yeah, the first one, the first successful launch is on 12th July 2023. So you can say it's still pretty new. It's like it's it's been 3 years since liquid methane as the propellant combination with the liquid oxygen basically in use. It's almost 3 years by now, so still lots of things we need to learn about the liquid methane part in comparison to the liquid hydrogen. But technically, if you want the denser part, you still want the cryogenic part, but without the super aggressive cryogenic part of the liquid hydrogen, you can use the liquid methane. So that's how it works. Okay, and just to give you some quick updates as well. Okay, so this is the so this is the forum from the NASA spaceflight forum. Okay, that specifically discuss about this one. So also mostly credit to Mike Zhang here, Mike Zhang, for compiling lots of stuff here, so we can peruse here. So you can see the NOTAM, the Northeast to Airman. This is the this one I believe is the drop off for the first stage booster on here. Let me see. Let me zoom in. Okay. Yeah. So if you see on this marking here, is this one, I believe is more on the first stage booster landing here. Okay, first stage. Okay, this is the first stage booster drop off, and probably at some point, maybe if it's not first stage booster back, this could be the strap on boosters, these two side boosters of it, and then later on, another notice here you can see is the drop off on the possibly the first stage or the second stage, but second stage by then should have already gone orbital. So from my conclusion, this could be the first stage. So yeah, this is the NOTAM notice. This is overall. So yeah, if you're living around the Southeast Asia part, especially from us here in okay, where is it? Yeah, in Borneo here. Oh no, wait, lost this part. Oh boy, yeah. So this is basically my homestead right now. Oh crap. Sorry. So okay. Looks like I have met how. Let's do this. So this is my homestead here, Sarawak. So if you're located around this drop zone area, especially from us here in Borneo as well, so please be careful because there's going to be first stage booster being landed back here. So it doesn't matter from where you are watching. If you're especially from for my local people in Sarawak and also surrounding the Borneo area, and also please be careful, watch out for the first stage booster reentry. You will see it on the side. So yeah, and also, how do I say, you're welcome, because I need to tell you something. I need to be very honest with you. Malaysia Space Agency, they are pretty worse on the space domain awareness side. Okay, I mean, seriously, every time they go with that notice, they will just come out and say it's like, I remember they come out and say it's like, hey, we are still investigating about this stuff, blah 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 blah. Come on, what are you even talking about? Even just some small perusing around the NASA spaceflight forum would have already told you what booster is it. So I can tell you, I pre-confirmed you right now, this booster, these rocket launches will be the reason why you will see it streaking around the sky. So if you're located somewhere around that affected area, especially for us here, very near to the first stage booster landing back, doing this reentry atmospheric destructive entry burn, you need to know this rocket launches is the reason why. Okay, so please take note about it. So thank you so very much, and you're very much welcome. Even though no one asked you, but well, I guess better be safe than nothing, and especially because I've already informed you way earlier than Malaysia Space Agency would do in their lifetime. Okay, and T minus 55 seconds. Okay, so looks like it. We are getting ready for the go. Okay, so get ready as we are preparing T minus 40 seconds. Okay, so here we go. The umbilical arm tower has already retracted by now. Yeah, I don't know. Yeah, that's the better one we can do. But we are getting ready for the launch of the Long March 8. We don't know the flight destination, but what we know is that it's going to launch the Qianfan Jigui, aka known as the SpaceSail Polar Group 08, 18 satellites on board launches for this Long March 8 launch. Get ready. Okay, looks like we have ignition and liftoff from the Wenchang commercial space launch site of the Long March 8 rocket carrying the Qianfan Jigui, the Space Sail uh, Polar Group 08, 18 satellites on board on this mission. We have liftoff. The liftoff specific from the launch pad of the launch complex 2 or 1, but either way, here you can see right now the rocket launches has already been obscured by the cloud. Okay, and what happened here then? Okay, looks like we have overstretch of the screen, but either way, you can see the rocket flames is still visible even amongst the cloud. Okay, and at T plus 50 seconds, looks like the flight is good. Okay, and we have tracking back again. Okay, we have tracking. T plus 1 minute, getting ready. Should be supersonic by now. Okay, here we go. Looks like from what my deduction there, by now we should have already gone into the max Q region, the maximum aerodynamic pressure, the peak mechanical stress fully exerted on the rocket itself. Okay, and but for whatever funny reason they play around the fireworks there. Okay, but that's it. That's the mission so far. Okay, so that's it. Okay, the fireworks still can be here, but not really very significant in any way. Okay, so this is what you're looking right now at the almost T plus 2 minutes in. This is the launch pad already clear. And so far, the mission's preliminary looks good. T plus 2 minutes and 4 seconds to the flight. This is the launch current view of the launch site of the Wenchang commercial space launch site here, located in Hainan Island, China. So that's that. Yeah, and unfortunately, looks like the weather situation with the cloud cover doesn't give us the best view. But however, this is as best as we can get. So yeah, thank you so much everybody for watching, as we are still waiting. Okay, and that's it. Thank you so much. And that's why you're looking. Next will be the Starship Flight 12. Probably I will also going to use international rocket launches stream again once more time, because it's much easier to just have it consolidate into one, and plus much more clearer sign if it's going some countdown as well, in case for whatever reason SpaceX decided to just remove the time countdown. We still have from the international rocket launcher. So yeah, thank you so much everybody for watching. And yeah, please stay safe, and please be aware of the space debris as well, especially because we are pretty close with the first stage booster reentry. So if you do see on the social media, and there's like some views there, and I know we do have a very good sense of humor here. Sometimes we call it like the Autobots landing back on Earth, Venom, whatever. I really like our sense of humor here. But just stay aware. And yeah, that's the best I can do, because I know Malaysia Space Agency, they will just say like, oh, we're still confirming. Well, this stream already confirms that's the booster, is it? So please take care, and please stay safe of it. And yeah, don't be panicked if you see it re-enters back on Earth. So yeah, because I know there's like some how do I say, like some viral video before the where I also previously also covered the launch of it, if I remember, the group 06. Yeah, people just viral it on the social media, but I already knew about it because I already show you, because back then, even then, I show the notice to airmen. So please take care, okay, and don't be panicked if you see it on the social media. Just let them know. Just let them know. Didn't Sugo already inform you guys of that? But how do I say? I'm not going to sound like wanted to take credit, because no, not really. It's more like collaborative effort, and the first source I get is from the Mike Zhang, from one of the NASA Spaceflight Forum member. That's where I got the source. Yeah, because it's a bit hard trying to track this source down here and there, but that's it. That's the best we can get so far. So thank you so much everybody for watching. As we are going to watch the next launch, I'm going to use the next space flight. This one is basically like the web app slash mobile app affiliated to NASA spaceflight as well. I'm going to show. Okay. Oh, I forgot to put this notice up, but it is what it is, alright. It's okay. But yeah, the next rocket launches will not be the Spaceflight 12, but instead would be the SMILE spacecraft launch. This one is the Solar Wind Magnetosphere Ionosphere Link Explorer. So I'm going to stream this. Hopefully there's no kind of delays and whatnot, because a little bit scary. They did not 100% fully show it off, but from the stream, okay, you can see, looks like it's going to happen 36 hours from now, aka on our time here, it will be on Tuesday, okay, because we in Sarawak and we are in Borneo mostly, we are 8 hours ahead of the universal time coordinate. It's 11:52 a.m. launch on 19 May 2026 on Tuesday. So we are going to see that soon. This one is the joint mission between the European Space Agency and also Chinese Academy of Science. Okay, so we are going to see that. This one is basically this one is essentially a culmination mission of all space science. All of this of the heliophysics and also magnetospheric and also ionospheric mission. These three missions all together, these three heritage mission all together culminated even back around 1995 up until this day, culminated into this one mission, this SMILE mission. This one is to improve our knowledge and understanding of how our Earth interact with the how our Earth interact with the solar flare, and how our Earth also protect itself from various kind of element, especially very important for the space weather prediction as well. Very important this day, because otherwise, if it hits to our Earth, let's just say if the solar flare flux amount way too much, it could damage lots of satellites communication, and also with the power grid as well. Not very good for us here back on Earth. And also, especially try imagine this, even very simple stuff like GPS, if it doesn't work, what happened? You will not get any kind of guidance. Probably everyone will just flying blind uh, here and there. So yeah, thank you so much everybody for watching this stream. I'm Dennis Suguwa, your host today for the launch of the Long March at Rocket carrying Qianfan Jigui. Also, basically in English, it will be SpaceSail Polar Low Earth Orbit Group Group 08 from A to R, aka 18 satellites per constellation here for this launch. Okay, preliminary so far, it looks pretty good. And yeah, that's it. And yeah, stay safe everybody for out there. Especially please do not be very please do not be very alarmed if you see it ran to spec. Just make sure not to go around the designated not booster drop off area. Okay, please be careful, especially to fellow Sorokin, fellow Bornean. Please be very careful. Okay, so thank you so much everybody for watching. We shall see you soon for the launch of the Vega C rocket. Vega C actually stands for Vega Consolidation, that will carry the small spacecraft, which will be 36 hours from now. 36 plus hours from now. One day it will be around 1 day and 12 hours plus from now. So thank you so much everybody for watching, and stay safe and take care. Bye bye, and see you later on. And that's it, we have already finished this one. And yeah, I can say I'm still if you hear from very early on, I'm still quite I still have sort of my kind of cough here and there. Yeah, I'm slightly sick right now. Fortunately, a little bit good health right now, but yeah, I'm still going to watch out because my throat is basically in borderline. Yeah, it's really on the borderline side of situation. If I don't care of myself, who knows, I'm not be able to stream as usual. So yeah, thank you so much everybody, and see you soon. Bye bye, take care.